Some years ago, more than one famous website learned the same lesson the hard way. Everything was fine, caches were humming, and then one single cache entry expired. Seconds later, their databases were on the floor. By the end of this video, you will know exactly how one expired key can do that, and how to make sure it never happens to you. But first, the pattern that runs most of the internet. It is called cache aside, and you already saw a glimpse of it in episode 1. A request asks for player 42. The app checks Redis first. If the answer is there, that is a cache hit, and we are done in a blink. If not, that is a miss. The app fetches player 42 from the database, returns it, and drops a copy into Redis, so the next 1,000 requests never touch the database at all. But a cache copy is frozen in time, and player 42 keeps racing. His cached profile slowly drifts out of date. So every cache entry gets an expiration timer, called a TTL, time to live. Store his profile with a TTL of 5 minutes, and Redis deletes it automatically when the timer hits 0. The next request misses, fetches fresh data, and the cycle restarts. Stale data has a built-in shelf life. And when something changes right now, you do not wait for a timer. Player 42 buys a new car. The app updates the database and then simply deletes his cache key. The very next read rebuilds it fresh. Update, then delete. That little dance is cache invalidation, and there's a running joke that it is one of the 2 genuinely hard problems in computer science, alongside naming things. Meanwhile, memory itself is a budget. Redis lives in RAM, and RAM fills up. When it does, Redis evicts entries to make room, and you choose the policy. The favorite is LRU, least recently used. Throw out whatever nobody has touched in the longest time. A cousin called LFU keeps whatever is used most often. Either way, the cache quietly curates itself, keeping the hot data and shedding the forgotten. Now, back to our disaster. Here's the setup. The game homepage shows a featured tournament, cached under one key, read 10,000 times every second. That key reaches the end of its TTL and expires. Pause for a moment. 10,000 requests arrive in the very next instant. What do they all do? They all miss, and they all charge at the database at once, each one trying to rebuild the same cache entry. That's the cache stampede. The database, shielded for hours, suddenly takes 10,000 identical queries in one heartbeat and falls over. One expired key. Total outage. The fixes are beautifully simple. 1. Use a lock so only the first request rebuilds the entry while everyone else waits a beat and then reads the fresh copy. 2. Add jitter, small random offsets to your TTLs so 1,000 keys never expire in the same second. 3. Serve the slightly stale copy while a single background job refreshes it. Any one of these turns a stampede back into a single polite database query. So here's the big picture. Cache aside serves hits in a blink and rebuilds on misses. TTLs give staleness a shelf life, deletes handle right now changes, eviction keeps memory honest, and stampede protection makes sure one expired key can never take you offline. But all of this assumes Redis itself stays alive. So what happens when the Redis server dies and takes your entire cache with it in one power cut? That's next, and the answer is cleverer than you think.